A quick reminder that the team formation for the project is due Friday. You have to fill out this team formation form. I'm not going to be logged in. I am logged in. You have to fill out this team formation form. Either I want to be placed in a random team, and that's it. Or you formed a group of 4 members, you found a team, and you want to tell me who your 4 members are, who your 3 teammates are. You got to fill that out by Friday. If you don't fill it out by Friday, I'm assuming that you're going in a random team, and I'm going to take all the people who did not fill out the form and put them in groups with each other. So just so you know, so if you're not filling out that form until after the deadline, chances are you're getting put in with other slackers. So just so you know my plan on that. It's in your best interest to form a team, or at the very least, fill this form out as early as possible, if you want to be put in a random team. If you don't want to get put in with the people who can't even fill out a form, probably not going to make the best teammates, if I'm being honest, which I always am. So team formation due Friday. Get in a team. I just emailed everybody yesterday, I think it was, who didn't fill out the form, so you got an email reminder as well. There's no excuse to not fill this out. I don't want to hear any, we formed a team, but we just didn't fill out the form. We got put in random teams now. Can you please put us in a team? I'm not doing it. If you can't fill out a form, you're not getting the team that you chose. Fill out the form. It's not that hard. If you're still forming a team, get in Piazza, get in Discord, talk with your classmates, try to form up a team. Try to find a team who's looking for another member, and get your team formed. Get your teams formed. I also posted some documents in the project section. The team meeting form, this link was live before, but that was kind of an oversight. It was live pointing to last year's form, but it's updated for this year's form. Of course, that doesn't apply until week 3, so till next week. So for what it's worth, this form is updated. And I also posted some documents on the project requirements and the presentation. So all the information about the project is out there. If you have any questions, any clarification that you want, or anything that's not super clear, look through the project requirements. Feel free to ask for clarification, either during the chat and parts of lecture, before and after, on Piazza, etc. But I gave a little more explanation for each of the 5 criteria, what does and doesn't count. One important thing is you have to use your own database. So services like Firebase, those are not going to be allowed. Now that I think about it, I think in the syllabus I actually mentioned Firebase. Yeah, I have to erase that. Firebase is not allowed because I want everybody to get practice using a database in Docker. So that's not allowed. Things like OAuth are allowed, but you have to write a full report, if you want to use something like OAuth. And you still have to store things. So little details like that about all 5. Actually, I don't add anything about this, but the reports need to be in a directory. You have to use Docker Compose, which is something we'll talk about when we talk about databases. Docker Compose is a layer on top of Docker, so everything we talk about today still applies, and you add one layer, Docker Compose, on top of it. You can have a private repo, but if you have a private repo, you have to add me as a collaborator, or otherwise give me access to your repo. But I have to be able to see your code, and then you might also be asked to add some TAs as well, but we have to get in there so we can grade your stuff. If we don't have access to your stuff, it's private to us. There's nothing to grade, and all we can do is give you a 0 at that point. But if you want a private repo, if you're worried about your code being public, I will allow that, but you have to at least give me access, and then I'll share that access with the TAs, or ask you to give the TAs access directly. And is there anything else I really want to say? Just a reminder about the project checkpoints. Whenever you want to use a checkpoint, use this form. Give me your GitHub link. Give me some information about your progress through the project and any comments you want. Once you fill out this form, I'll see that you filled it out, and then I'll go through the checkpoint stuff. Whether the TAs or myself will go in there and take a look at what you have. Probably both. I'll probably have the TAs do it, and then I'll double check things. Yeah. So once your teams are formed by Friday, and you have your first meeting next week, I would look through this document and try to figure out what you want to build. So whatever you're building, make sure that you're fulfilling. Oops, that's 442. And this should be down. And make sure you're fulfilling these 5 criteria. Whatever your idea is, and feel free to bounce ideas off of me. Say, hey, this is our plan. This is what we want to do. Does this fill these 5 criteria? We looked at the doc. We think it does, but we want to make sure before we go ahead with this plan. Feel free to do that. But you have to fulfill this 5 criteria. There's a lot of flexibility in what you build. There are a lot of different things that you can implement that meet these 5 criteria. So I wanted to make these criteria not too restrictive, that whatever idea you have, you should be able to implement these 5 features as part of that idea. Even if you weren't planning, maybe you want to make a game that you wouldn't plan on having a DM server, a DM feature, add a DM feature to it, and then you can still build what you want. You don't want multimedia content. I gave an idea, and I'm hesitant to even do this, but I put it in the doc, and I'll share it here. You have to be able to share multimedia content in a way that other users can see the multimedia content that other users have shared. This might not fit into all the ideas that you have, but the suggestion I made, which I'll probably see everybody doing this. I'm not really thrilled about it, but whatever. I'm committed to this. Is updating your profile picture. So if a profile picture shows up next to your username when you make posts and stuff, that's sharing multimedia content. You uploaded an image and other users can see that image. You've shared multimedia content. So I don't mean this strictly as in like you have to be able to make multimedia posts and people can like and comment like a social media app. It can be any multimedia content that other users can see. Profile picture is probably the most straightforward, easiest way to do that. But if there are questions, actually let me scan, see if there are questions. Let us start some lecture. Yes, let's get into some lecture. So we can't use something like Azure. You have to host your own database. So you can't use Azure as your database. You can use other features, but no offloading the database work. Would it be realistic to implement everything originally? If you want to learn a lot, I mean, it's certainly realistic, and you wouldn't have to write any reports. If you mean treat this like it's a homework assignment and build it from scratch, I think that's realistic, and I think you would learn a ton. It will absolutely be more work than using frameworks, but it's something that's possible. A few teams tried it last year. They were not successful, so I wouldn't attempt that unless you really know the material. I think those teams did that because they didn't know what they were doing and they just wanted to reuse their project, their homework work that they've done there. So in those cases, it didn't work out. But if you know what you're doing and you want to really dig deep in the details and do that, go for it. Could reaction emojis count as multimedia content? Only if users can upload their own custom emojis, then it can. Can we use Django ORM? I believe so, but I'm not 100% remembering what that is. But I believe that's self-hosted. So yeah, anything that's self-hosted you can use. I believe that's their object relation model. Yeah, that's how Django interacts with the database. Yes, that's allowed. But you can't host, what I mean is you can't host, and SQL Server is obviously allowed, MongoDB. All those tools for working with the database are allowed, and the database servers themselves. What I'm saying is you can't offload your database to an external server. Your database and data has to be in your Docker, in your build on your server. You can't say, hey, Microsoft, hey, Amazon, hey, Google, you host my data for me, and then I'll just connect to you. You can't do that. Can we add chat box to your 442 website? I actually removed the chat from the 312 website because most people didn't find it, and then even when I showed them, they didn't use it. Just not a feature we need. All right. Do we have recitation? No. So officially, recitation is your weekly team meeting. So there's no recitation that I'm gonna like me and the TAs are gonna be there, but it's your weekly team meeting, and then you fill out the reports so we know that you've been fulfilling that because we have to have that hour. All right. Okay, we got to get into lecture. Docker. Let's talk about it. So let's talk about a little vocab and a little build-up before we get into Docker proper. So a few things that I'll be saying throughout the course. These things, these two different things, development environment and the production environment. Development environment, that's where you're writing your code, wherever it is, either on a laptop, a desktop, whatever your development machine, your device, your development environment is. That's what we'll call the development environment, and we usually show in that just dev. How it ran good on dev is something that we'll say as developers. And this is where you're working on code, you're finding bugs, you're fixing bugs, you're doing your testing. Production, on the other hand, is where your app is live. This is where your app is eventually going to live the rest of its life. This is a production, I'm using production to define it, but this is a server that's going to make your app live to the internet. This is where your actual users are going to interact with your site. Your users are never going to interact with your dev environment. They will interact with your prod environment. So once you push to production and go live, that's when your users can see things. And if you have bugs in production, that's when your users get upset. You start getting bug reports and things like that. So dev, like I usually say dev and production, now that I'm thinking about it. Dev and production are the two different environments, two very different places where your app is going to be ran throughout its life. In a development environment, you have a lot of issues that I'm sure some of you at the very least have heard of if you haven't been personally affected by this. It's the old, it works on my laptop kind of bugs. So your code runs on your laptop great, you run it, everything works, and then you push to production, you run it on the production server, and you send it to Autolab, or you send it to whoever's grading your work, and everything's completely broken. This is an app that only works in dev, and it completely breaks in production. This is a very frustrating problem to have, and pretty common actually. It's pretty common to have this issue, or at least it was. A way to solve this issue is to use virtual machines. So with a virtual machine, we're going to simulate an entire machine running within our machine. So on your laptop, you'll build a virtual machine, which is simulating an entire device, an entire machine, whatever you want to call it. It's simulating an entire operating system and running your app in that environment. So this is the way that the VM is built, it's going to be exactly the same no matter where it's running. So you have software like VirtualBox where you're going to run the VM on your laptop and run VirtualBox on a production server, and you're going to have the exact same virtual machine no matter what the differences between your two environments are. So maybe your dev environment is a Windows machine and you're deploying to a Linux box. It doesn't matter because you're using a VM. You're going to run a VM in both. And then whatever your VM is, that's where your app is going to actually run. So this is a nice solution to that headache that we just mentioned. Now we don't get it works on my laptop but not in production, because you test it in the VM, the exact VM that's going to be used in production. So you don't have that issue. In your development environment, you spin up a virtual machine, a copy of that production environment, and you run that same virtual machine in the production environment. No issues. I shouldn't say no because we still have issues from time to time. There are still some certain specific things that can go wrong, but they're very minimal. They're very much so minimized when we're using an approach like this. So this is something that solves a lot of deployment to production headaches, is using these virtual machines. There's also a security gain here. If we're running that code inside a VM, the code, ideally there are some very obscure, sophisticated ways to break out, but it's very extremely difficult to break out of the VM. So if you're running a VM on your machine and that VM is compromised, say the attackers get into your server, you have some vulnerability, attackers compromise the entire server, they should only be able to compromise that virtual machine, and they're not able to break out of that VM and actually destroy your hardware, gain access to the larger server. So you could have a production server, an actual physical box, a server box, that's running multiple virtual machines for different apps. And if one app is compromised, the attacker doesn't gain access to all of the apps running on that server, or even all the apps running on that network, potentially. They're contained inside that VM, so they can't really, they can't break out of it. They can't destroy all your stuff. They can't steal all your data. They only can compromise what's in that VM. So you destroy that VM, you patch the vulnerability in dev, you redeploy it to production, spin up a brand new VM, a fresh instance of your app with the patches applied, and then go forward with that. And hopefully you had your data backed up. You can upload your data from your database again without the attackers, whatever they injected. If that be the case, that you can be back up and running with the new VM. PyEnv, is that like a VM? It's not a full VM, but I'm not. John's got us here. Yeah, I believe it's more lightweight though. I don't think it's. I'm not sure if it gets the security aspect. It might though. I'm not positive. But yeah, it's specific to Python. rm-f and then the slash. This is something you never, ever, ever want to do. Never do this. So rm is to remove a file. Actually, I think there should be an R in here too. -f means force. So sometimes you try to remove something. This is for Linux environments. Sometimes you try to remove something and it says, yo, you sure you want to do that? The -f says, yes, I am sure I want to remove this. And then the slash, that's your root directory of your machine. So rm-f slash, and I think an R, I'm not sure if you need the R or not for recursive. This just deletes everything in a Linux environment. If you do this, you might need sudo, but sudo rm-f slash just deletes everything. Your operating system, all your data, absolutely everything, until it gets to the point where it can't even remove stuff anymore because you've destroyed so much of the box. Just completely destroys a Linux machine. But in the spirit of Linux, Linux lets the user do whatever it wants and doesn't hold them back. So Linux will let you do this. There's nothing wrong with doing that. It says, oh, the user wants to delete everything. Okay, I guess I'll delete everything. The security aspect is nice for if there's a vulnerability in your app, but there's also certain services that require allowing users to inject code. There's what's called code injection attacks, where an attacker injects their own code into the server and gets it to run. A lot of like SQL injection attacks, they'll inject their SQL code and get their code to run. That's one of the big goals of attackers. But there are actually a lot of apps that require allowing injection attacks by the nature of the app. For example, Autolab. We run student code in Autolab. By definition, Autolab is vulnerable to code injection attacks because that's exactly what it's supposed to do. You're supposed to send it code and it runs that code. So if your code says run a syscall for rm-f slash, well, you just delete everything. You just delete Autolab. We can't have that, so obviously we have to run your code in a virtual machine. So Autolab actually runs a brand new environment for each code submission. So even if you destroy that I have to start using the word container here because it's technically containers at that point. You can destroy that container, but you can't destroy Autolab itself. All you do is destroy that container, which, guess what? As soon as your code's graded, we destroy that container anyway. So if we destroy a destroyed container, whatever, no big deal. AWS, Heroku, DigitalOcean, any hosting service where you're able to upload your app and they run it for you on their servers, they have to use some virtualization or containerization to be able to protect themselves from your code because AWS doesn't want to allow every user to be able to destroy all of AWS. That's hopefully I don't have to explain why that would be bad. But there are apps that have to have this security feature. So run users code in a VM or a container. These days, it's all about containers. This is the hot new thing. Not so hot anymore. They've been around for a while now, but they kind of took the dev world by storm when they were introduced. They're effectively lightweight VMs. So we get all the benefits of a virtual machine, but without having to run an entire simulated machine on our in our environment. A virtual machine is like a whole copy of a machine. Containers, they share a lot of the overhead with the host OS, and then just run what they need to inside the container. So we still get the effect of VMs, but a lot more lightweight, a lot less resource intensive. And we're able to run multiple containers simultaneously without running out of resources very quickly. The resource sharing between containers is a lot more effective, a lot more efficient. So this is what we're going to use Docker for. Docker is software that's used to create containers, these lightweight VMs. So we don't have to, anyone who's ran a VM on your machine, if you want to dual boot or something like that, or install VirtualBox and have multiple, dual boot actually doesn't have that problem. But if you want to run VirtualBox and have two operating systems running simultaneously, you know how much of resources that takes away and how slow your machine can get when you run that. So we want to avoid that. We don't want to chew up all of your resources to run these containers. So Docker is what's going to be our solution for this. We use Docker to create these containers, which are effectively lightweight VMs. So this is extra software. This is its own software, Docker. So you do have to download, install Docker onto your machine to be able to run your containers and run your Docker files. So the first step, there's a link on the course website for today. Go to Docker's website, download, install. Just regular software, download and install it. And then it runs in the background and waits for Docker commands for you to tell it to spin up some containers. Yeah, Docker's pretty standard. So this is getting a little touchy these days. Docker's an industry standard right now, but there's something called Kubernetes. Google is trying to take over Docker, it seems like. They're getting... I haven't followed this entirely closely, but from my 1,000-mile view, it looks like Google's getting pretty aggressive in trying to take over Docker with Kubernetes. Getting Kubernetes to overtake Docker. So Kubernetes might be the thing that you hear about more and more as time goes. But Docker was at least the first industry standard in the containerization world. I think it's still the standard, but Kubernetes is trying to take it over. Doesn't Kubernetes manage more managed containers? Yeah. But I heard Kubernetes is dropping support for Docker. So Kubernetes is not going to manage Docker containers anymore. They're going to replace that with their own container standard. So if you're using Kubernetes, you might... Again, I haven't followed the story completely, but if they're dropping support for Docker, you won't be able to use your Docker images anymore in Kubernetes. So you're going to have to switch to whatever Google tells you to switch to if they're dropping that support. But I haven't confirmed if they are dropping support or if that was rumors or not, or what the timeline is. So time will tell. But for now, Docker's the way to go. But Google's a big player in the game, so if they say no, they like it or not, they have a lot of power. They got a lot of pull in the dev community. So to create a Docker image, we'll talk about, we use containers, we will create Docker images, and we use Docker images to create Docker containers, and an image can be used to create multiple containers. Then we can use something like Kubernetes or Docker Compose, which we'll use to manage multiple containers that can communicate with each other. So if we want to build distributed apps and even distribute those apps across multiple machines, we have a Docker image, which is going to be used to create many containers across multiple machines, and they can all communicate with each other. So to start working with this, we need a Dockerfile. A Dockerfile is similar to a Makefile, but used to create Docker images. So a Dockerfile is going to tell Docker how to create a Docker image. And here's a sample Dockerfile. We're going to spend like 10 slides. We're going to go through this line by line and talk about everything that's in this Dockerfile right here. So let's take some time and go through a Dockerfile by example. And this is going to spin up an app. I have an app www.js in this example. that we want to run using this Dockerfile. This is the ultimate app that we want to run. Without Docker on your machine, you would just do node app-www.js to run this thing. But to spin up a Docker image to be able to run this, we're going to run this Dockerfile. So first thing, we're going to start with and DevOps is the buzzword. I should have added that to my vocab slide. DevOps is the word for everything we're doing here. Anything that's deploying the app in production, that falls under the DevOps umbrella. So the first line of your Docker file is going to be the image that you want to start from. So there are lots of different Docker images that you can download for free and use that as your base image for your containers. And in this case, I'm going to start with an Ubuntu 18.04. Someone mentioned, why not Ubuntu 20.04? I was going to change it. I was going to update the slides, but I didn't feel like testing to make sure that Ubuntu 20.04 had a Docker image all prepared and ready. So I just left it at 18.04. But if there is a 20.04 and you want to use 20.04, go for it. Use whatever you want. But I'm going to start with a fresh install of Ubuntu 18.04. So with just that line, I already have Ubuntu, a full instance of Ubuntu running in my Docker container. If I left it as that. So if I just want effectively a lightweight VM of Ubuntu, that's it. One line, that's my Docker file. I run that line, done. But we want to do more than that. We want to run a web app. So let's add some more lines to this. Yeah, you can use Python instead of Ubuntu. And I'll show that. I'll talk about that later. I want to go through this one because it's a generic. You can do anything with this, starting with Ubuntu. And then I'll talk about the language-specific ones in a sec, once we get to the end of this. Then we use the run keyword. Yeah, you can use whatever image you want. So then we use the run keyword to run commands inside of that image. For Ubuntu, this is just like running these commands in the command line. So if you had a completely fresh instance of Ubuntu, and you went into the command line and started running bash commands, it's the same thing we're doing here. We're using run to run those commands. And these do run as root, so we don't have to add sudo to every single line here. It's already assumed that that Docker has root access inside this container. So it's not sudo apt-get update, it's just apt-get update. You can drop the sudo. It's not needed because we're already root. So run is going to run commands just like you're in the command line. So anything that you want to run, if you have a fresh instance of Ubuntu, whatever you have to type into that command line to install the software that you need to run your app before running it, you're going to have to add that to your Docker file with run commands. Next, this is just something I like to do. I think I got this from some documentation somewhere, and I liked it enough that I do this in every Docker container that I create, is changing the root directory, or changing the home directory to some known directory. The documentation I followed, I believe I got this from docs. Use /root, which I liked because I'm running as root. It makes sense. So I'm going to change the home directory to /root, and then also cd into that directory. This work dir, short for working directory, is the same as cding into a directory. So I'm going to change the working directory to /root, change the home directory to /root. Now, if I ever have to enter into a container, which I'll demo on Friday, if I ever have to enter into a container and navigate its file system, I know where to look. I'm going to enter into the container. I'm going to go cd /root, and then I'm going to see all of my app files right there. Instead of, I don't even know what the default is. I just do this so I always know where my files are going. So the working directory is /root right now. If I need to change that working directory, work there, if you ever want to switch to a different directory. Then I'm going to run any commands that I need to install the software that I need. This, if you're starting with an Ubuntu image, you're going to, at a minimum, have to install the dev tools for the language that you need. So here I have a Node app, a JavaScript app. I'm going to install Node. I'm going to install NPM. And this fix missing is something that I need to do to get this stuff to work. I'm not positive if that's needed anymore these days or not, but it was needed when I set things up. So I'm going to leave it there. It's not going to hurt having it there. So whatever you need to do to install, if you're installing Python or Java or Scala, C++, whatever dev tools you need, whatever compilers you need, whatever you need to run your apps, all that stuff is going to have to be installed, because unless it's pre-installed with Ubuntu, because you need those things to run your app. Next, this very important line, copy all of your app files into this image. Copy ... The dots can be different. You can add paths. These are full paths. Dot means the current working directory that you're currently in. So if you have this Dockerfile in the root directory of your project, then dot, and you're running Docker from that root directory, then this first dot is going to mean the directory that I'm currently in, which is the directory where you have all of your app files. Copy all of those files in this directory, and recursively all subdirectories, into the current working directory inside the image, which is going to be /root. So copy everything in this directory into /root into the container. So you're getting all of your app files inside the container. Very important line. Without this line, you're not running your app. You're just creating a fresh Ubuntu and then installing some things. This line, probably the most important line. Copy your files into the container. Now that my files are in there, for Node, this is going to include oh my goodness, I forgot what it's called. Some.json or, I forgot. But whatever the dependencies file, I forget what it's called, for Node, download all those dependencies from that file. It's very important to do this after I copy my files in to run npm install package.json. Thank you. It's important to run this after I copy my files, because before I copy my files in, there is no package.json, which tells npm what packages to install. After I copy my files in, run this, which will look for my package.json, look through all my dependencies, and download all those dependencies. Very important to do this after copying your files, because it doesn't make sense to do it before, if you're thinking about what's going on here. Next, expose 8000. This is going to expose a specific port from the container. So containers are meant to be, go figure, containerized, and everything should be contained within the container. So by default, everything's closed off. You can't access this container from the outside world, and that container can't access the outside world. It's completely isolated. It's an isolated environment. So for running web apps, we don't really want that, because we want people to be able to use our app. So we're going to use expose and then a port number to expose a TCP port to the outside world. So expose 8000 is saying allow access to port 8000 from outside this container. So now port 8000 and only port 8000 is able to be accessed from outside the container. And this app, I won't show the code for this just because I forget where it is. It's just a generic Node app. I'll show Node apps eventually. But this app does run on port 8000. And then finally, running the app. For this, do not use run, as counterintuitive as that might sound at first. Don't use run. We use command, CMD, to actually run our app. And this is typically the last line of your Dockerfile. It's going to be command, and then how to actually run your app, whatever command you type to run your app. It's very important that this is command and not run. Run is going to execute when you're building an image. So we're going to download Ubuntu and then type in this, set this environment variable, change the working directory, run this line, etc. When we get to command, this is not executed when the image is being created. This is not going to execute until we create a container using this image. And that's when we want this to run. So command, that's going to run when we start the container, not when it's building. So we have two different steps to this process. It's kind of like compiling and running your code. You're going to build the image and then run a container based off that image. It's kind of like compiling your code. Compile, we run all this. And when we run all this. It's basically saying, like, this is the main method, is kind of the analogy. So let me stop for a second here. Are there any questions about this Dockerfile and what's going on here? My shoulder keeps hurting each stream. I don't know how I'm sitting or something, but my right shoulder. It require. Oh yeah, Memtronics S. Yeah, requirements.txt is the Python equivalent. And in 1.16, if you took it in Scala, our pom.xml would be the Scala equivalent. But most languages have some convenient way to specify your dependencies so they can all be downloaded without us doing a lot of work. Where's the Dockerfile in relation to your code? The root directory of your project. Can you explain command again? So command is going to run when we start a container. So when we actually create a container based on this image. So we have a little vocab, Docker images and Docker containers. Where the rest of this is going to be executed when we create an image as opposed to a container. Copy ... from where to where. The root directory of your machine to the root directory, or the current directory, the current working directory of your machine. So wherever you were in your machine when you typed Docker build, and the current working directory inside the image, which in our case right here, we changed it to /root. So /root inside the image. What is the app www.js, www? I forget what exactly that was. I think it was just some simple JavaScript app. I'll show some Node apps at some point, but I forget what that one actually did. I think it was just I might not even actually create it since I'm using this just to show Docker. But that'll be a Node app that exists in your directory in this example. Yeah, requirement 1 of homework 1 is setting up Docker. Which again, I recommend doing objectives, at least objective 2 first. So as you're going through Docker, you have something to test Docker with. So for Python, do we need to run apt-get update? This is updating apt-get for Ubuntu. Sometimes this is needed just to make sure you have the right repositories. So when you do these apt-get installs, we want to make sure that Node.js and npm are things that apt-get knows about, and apt-get update is going to give us the latest repositories to limit the errors that can happen down here. Do we need to expose 8000 for test objective 2? Yeah. Because your app has to run on 8000, so you would expose 8000 to be able to test it. Do we show a live demo? Yeah. We got 10 minutes. Let me try to get through these slides and show a quick demo. So you saw earlier the 442 website's intentionally down right now. I'm going to spin that up by creating a new Docker container, image and container. So you don't have to start with Ubuntu every time. Dare I say, all languages have a Docker container or a Docker image that's pre-built and freely available for you to use. And I believe they're still based on Ubuntu, but they take the Ubuntu image, run the commands to install whatever's needed, and then they make that image available for download. So for example, if I want to simplify this this Docker file, instead of installing Node and npm myself and doing the apt update and doing all this installation stuff, I'm just going to start with a Node container, which is a container where somebody already installed Node and then made that available to the public. So I'm going to start with Node version 13. I'm still going to set my home directory, my environment. I didn't explain environment variables much, but I'm going to set the home environment variable to root, which sets your home directory. I'm still going to cd into root. I'm still going to copy all my files and then run npm, but I'm working off the assumption that npm is already installed because it's part of this image. Node and npm are already installed, so my Node and npm that I'm using here are already installed because I just started with Node. And to find an image in your language, I won't go through examples of every single language that you're using. Actually, I might end up just by default by the end of the semester. But if you just find your favorite search engine and search Docker, your language of choice, you're gonna find like 1,000 tutorials about how to set up a Docker image with that language, and what language to start from. You'll get all kinds of good information, because I don't have enough time to go through every single language in lecture. All right. So, oh shoot, I forgot I have a few more slides. What to do with these Docker files. So once we have our Docker file, we can create a Docker image, and we're going to use this command in this class, docker build/t, an image name, whatever you want to name it, and then dot to say I want to build this from my current working directory. So you're going to cd into your project directory, the root of your project, and then run this to say, look, I got a Docker file in this directory, run that Docker file, build that into an image, and call it this. That's what that line's doing. Okay, so we got an image, but what we ultimately want are containers. So we got to use this container to build, or this image to build containers, which is very similar to using a class to create objects. We're going to use this image to create containers. To create a container, we're going to run this mouthful of a line. There's a lot of shorthand that you can use for this to really shorten this, but I want to give the expanded one it's just more verbose. It's more explaining what's going on here. So I want to run a container. I want to publish it on a specific port. This is going to map a port on your machine to a port inside the container. So inside the container, your app's running on port 8000, but you don't have to use port 8000 on your machine. So if you want to map this to a different local port, you can specify that here. Local port can be 8000. You want to map 8000, 8000. I ain't stopping you. -- detach is going to run this container in the background. I recommend leaving this off for debug purposes, and I'll show an example of leaving this off. And then the name of your image, which must match the name that you named your image in the previous step. Oh, yeah, I did add a slide on that. I recommend leaving off that detach. Detach is going to run it in the background, and then even when you log off that machine, that app is still going to be running, something we usually want with web apps. If you leave off detach, then you're going to be seeing the output of that container. That container will close once you actually does it. I've never even tried because it doesn't make sense. But it'll show you all the output for that container, and I'll actually show an example without detach. Which, let me get to that. And in your app, don't use localhost. We're used to using localhost. If you've done any web development, you've used localhost. Wherever you use localhost, replace that with the string 0000 as your IP address. This will make sure that your app is accessible from outside of the container, because localhost is local to that container, so you won't be able to access that from outside of the container. Replace that with 0000. It's the same as localhost, but it makes the app available from any source. Yo, John, glad I could help. Okay, let's get to this example. Wrong window. Okay, so we have I'm actually in the wrong directory because I was fixing something I broke. So I'm going to go into my CC 442 app, and I'm going to go to I'll show you the Dockerfile here. So from Python 3.8, super simple syntax, thankfully. This is an image with Python pre-installed, Python 3.8. I'm going to change my working directory like I did before, copy all my files into that image, run pip to install all my requirements. This app runs on port 5000, so I'm going to expose port 5000, and then run my command Python 3 app. And I use different syntax here. You can give it an array like that, or you can do it the way we saw it in the slides. So I'll change it to the way we saw it in the slides. And I have my whole app sitting here, all my code. I'm in the root directory of my app. So when I copy the files in, it's going to copy all the files from this directory. So I'm going to do docker build /t. I'm going to name this CC442, and then dot to say build this from the current working directory. And I gotta resize my window so you can see everything that's going on. And this is what's gonna happen when you build a Docker image. You're gonna get all this output. You're gonna see it running your lines one at a time. My goodness, stop. So like the first line from Python 3.8, it's gonna download Python. It's done downloading it. Runs my next lines. Says everything's fine. Here it's using cache. That means I've already, Docker does a lot of optimization for us. That means I've already ran this command and built that image and nothing's changed. So no problem with that. When we get to copy ... there actually was a change here. I updated one of my files. So Docker from this point on is going to have to run my steps. So it's going to have to reinstall all my stuff. Installing Flask, Socket.io, all these other dependencies. It's going to install all those, and we can see the output just like you were in an Ubuntu instance, typing in these commands into the command line. You're going to see the output of each one of those. We get this warning, the pip warning. I feel like pip always gives a warning whenever you run it, whenever I run it anyway. You can see the rest of our commands, and we have a successful build. We have a Docker image. You can see all your images. We have a Docker image named CSE 442. Go us. What did I... just for those of you who haven't seen that requirements.txt, I just have a list of the dependencies that I need. And then pip knows what to do to install these to Python. Now that we have our Docker image created, we can use that image to run the app. And I'll try to do this from memory. Docker run -p is short for publish. I'm going to map port 8442 to of my local machine to port 5000, and the image name is CSE 442. So that ran my app, and now I can see the output of my app as it's running. And if we go to csc442.com, looks like somebody went there. So somebody visited the site, and I can see all that requests. Actually, it might have been me. How come I didn't get more? But we can see the requests and the output of my server as we go to that site. So if you go to the site, you'll see more. Like that's probably a few of you going to the site right now, seeing that it's live, and I can see your requests. I can see all the output from my app. Everything that the app is printing out, I can see it here. That's because I didn't do this in detach mode. So let's kill this app. Does it really? Can we kill it? It won't die. Hello, class. What's up? Why can't I kill this? I mean, it's not the worst problem to have that my app won't die, but still curious. And Docker PS. Oops, I don't want to. My note there, Mike. It's not over yet. If we run Docker PS, so hey, that's it's nice to answer that question from earlier. So this does still run, even though I closed that other window and logged out of that instance. We still do have 442 running, even though I didn't use -detach. So I could kill that and then run this again. When I run this, if you do -d or -detach, that's going to run in the background. You won't see any output from that. Okay. Now, actually, one more thing. Not yet. Pico app. Just a few things. Instead of using localhost, I specified the host as 0000. And I'm running this on port 5000. That has to match the port that I exposed in my Dockerfile.